Welcome. In this video, we're going to discuss modular arithmetic and the word problems that are associated with them. So the key behind all of these problems is to pick the correct mod. We have to read what the problem is saying and then try to correctly deduce what type of loop is reoccurring in the problem, what repeats over and over and over. However big that loop might be will tell us the mod that we want to use for the particular problem. Okay, let's look at the first example. So if now is, so I look at my clock, it's 9:30 a.m. So 9:30 a.m. What time will it be 3,000 hours from now? And we're not going to worry about daylight savings. So this question gives us a little bit of a hint. It tells us we're going to use mod 24 to represent the 24-hour clock. We could use mod 12 and that would keep track of time, at least on a regular clock that cycles in 12, but it wouldn't keep track of the AM and the PM, where the 24-hour clock will do that for us. So every day has a loop of 24, so that's why we use mod 24 for this particular problem. Okay, so we're going to start with 9. We only need to keep track of the hours. We can worry about the half an hour, the 9:30 a.m. part afterwards. And we're going to advance 3,000 hours into the future. We would like to know what this is in mod 24. So I'm going to write a mod 24 at the end of my problem. That will mean that every congruence is trying to find the remainder when I divide by 24. So if we're doing this without a calculator, maybe we'll just think about multiples of 24 that are close to this number and keep making it smaller until we find the remainder. So how about we subtract 2400 and see what we get. So we'll get 9 plus 600. And then from 600, we could subtract 240. We could actually do that twice, take away two 240s, and then we would be left with 9 plus 120. And then from the 120, how about we subtract another multiple of 24? How about 96? So once we take away 96, we get 9 plus 24. 24 is 0 in mod 24. So it turns out for this particular problem, we don't change time at all, advancing 3,000 hours into the future, because it still ends up at 9 as the remainder when we divide by 24. So in this case, my answer would be 9:30 a.m. Okay, let's try the next problem. In this problem, we're going to be looking at days of the week, and in the current year, we're going to look at Valentine's Day. So we'll suppose the current year is the year 2020, and if you check, February 14th was on a Friday in 2020. So using this table, according to our mod conversion, the Friday would convert to 5. The question says, what day will Valentine's Day be in the year 2037? So what we need to do is start at 5 and advance in the future. So we're advancing along this loop around and around and around, starting at Friday, going around and around and around until we hit 2037. We just have to make sure we get the amount of counting that we do in this loop correct. So the first thing that we'll count is the number of years. So most years have 365 days. How many years we'll be wanting to consider? Well, 2037 is where we want to go to, and the difference between 2037 and 2020 is the number of years. So that will advance us 17 years into the future. But there's one more thing to consider too. If we want to be accurate, we need to know how many leap years to add on. So how many leap years will adjust for every February 29th that we cross over. So leap years are a little bit of an exciting story. They occur every 4th year for most of our lifetime. But if you hit 100th year, so 2100 or 2200 or 2300, those are actually not leap years. But wait, the story gets even more exciting. There's an exception to the exception. Every 400th year is a leap year. So 2400 will be a leap year. The year 2000 was every 400th year. It was also a leap year. If you look in a calendar, it is the exception to an exception. The year 2000 did have a February 29th. For this short time span, we don't need to really worry about all of that excitement. In the year 2020, we're going to have a leap year. And we'll cross over the February 29th. So that counts for 1. And then for 24, and for 28, and for 32, and then 36, there's going to be 5 leap years in this time span. What we have to do is reduce this expression in mod 7. So I'm going to take my pen and write mod 7 at the end of my problem to indicate that all the congruences represent remainders when we divide by 7. So working below, we'll copy the 5. For the 365 is kind of nice in mod 7. I always remember that there is 52 weeks in a year, so 52 weeks would be 52 times 7 plus 1 extra day. So the remainder, when you take 365 and you divide by 7, would be 1. So for that, we get 1. And then 37 minus 20 is 17, and then plus our 5 leap years left over. So we're reducing down. We've got 5 plus 17, we'll take away 14, and we're ending up with 3 plus 5, and then 5 plus 5 plus 3 will be 13. Finally, we can subtract 7 from 13 to get our final answer. In mod 7, we would get 6. So what does this 6 mean that we came up with? It means that the remainder of this number, whatever this number is here, it has a remainder of 6 when we divide by 7. So that means when we start at Friday and we count all the way down this loop over and over and over and over and over again, around and around and around, we eventually end up at 6. We started at 5 and we end up at 6. So Saturday is the day of the week that Valentine's Day will be on in the year 2037. So Saturday is our answer. So you can all start planning your love parties for that Saturday. It'll be a perfect day to have that celebration. Nice weekend day there for you. All right, so there's one more problem that I'd like to share with you today. And I'll let you pause the video for a moment and read through this problem and give it a try on your own. Okay, so this problem in essence tells us that there's 7 caskets, and these 7 caskets are counted in a funny way. They're counted from 1 to 7 first, and then they go in the opposite direction. Casket 6 was counted as 8, and then casket 5 was counted as 9, and it snakes back and forth in this pattern. So what's not obvious to me right away is what the loop is. So let's get a circle down on our page. Okay, so I want to use this circle to count caskets, and I want to count them so that I reveal when I start repeating a similar loop over and over and over again. So I start by looking at casket 1. I count that as 1, and then casket 2 and 3 and 4 5, 6, and then 7. Now once I hit casket 7, the next casket that I'll count is 6, but it's different from this 6 that I counted before. When I was counting this 6, I went up to 7. And now I'm going to be counting a 6 in the downward direction. So I think this is a different part of my loop. So I'm going to actually repeat writing 6. I count casket 6, but in a different way. And then I count casket 5, and then 4, and then 3, and then finally 2. And now I repeat to casket 1, and I do the exact same thing over again. I hit casket 1, and I repeat this process over and over and over again. So that's how the counting works, looking at the caskets. Now, as we count, we're going to actually count different numbers as we keep going higher and higher and higher around this loop. So let's try to attach a mod that keeps track of those numbers. So I'm going to get a different color pen out, and I'm going to do the counting. So casket 1 will be counted as 1, and then 2 counted as 2, 3 as 3, and so on, all the way till we hit casket 7. But that's when the funny counting started. We counted casket 6 as the number 8, 5 was the number 9, 4 was the number 10, 3 was the number 11, and then finally we hit casket 2, which is the last part of our loop, and we counted that as 12. But I'm going to think of, instead of counting it as 12, I'm going to think of taking all of my numbers and dividing them by 12 and finding the remainder. So I'm going to think of this as 0 instead of 12. Okay, so now we're ready to solve the problem. What I'm interested in finding is what is 5, 4, 3, 2, 1 when I divide by 12 and find the remainder. So if you do this, if you punch this into your calculator, or if you use long division, I'll let you try that on your own if you want to pause it for the moment. What you end up getting is 9. That should be your remainder when you divide by 12. Okay, so what does that mean? What does the 9 mean? It means that, let's say we were starting our counting pointing at 0. And then we counted 54,321. Counted to the number 1 and the number 2 and so on and so on and so on, around and around this loop. Around and around and around. Eventually we would hit number 9 in our loop, going around and around that many times, going around 5, 4, 3, 2, 1 times. So that means that our answer is casket 5. Casket 5 is the one that you want to open to escape this room. Thanks so much for listening. I can't wait to share the next one with you.